All right, we're doing an open loop DC motor control. This is the DC motor. It has metal gears. It has an encoder at the back. The encoder's got two ear looking thing on the very top. You can probably see it. Each one gives you an accuracy of where you are and gives you a reading for your RPM. The two are for, you can call them redundancy, but it gives you higher 8x accuracy, so you can get really good readings. Here we have hooked up the motor encoder to 6 and 7 pins, which match up with the Arduino saying your open 0 for A being the one of the encoders is hooked up to pin 6, and then B, the second EL that you saw on top of the encoder, hooked up to pin, oh, why did it say 4? That should not be 4. That should be 6. And that should be 7. Because that's what we just saw on the Arduino. And like down here, basically this is your Arduino. When you hook it up, we have data type conversion. We here say, previous step minus current step divided by TS. TS is set to 0.01 in this case, which is the smallest time step. 60 for seconds, 28 because we have 4 sort of count, I'm not really sure, but there's like on the motor, there are like 4 partitions or 7 partitions within the 1 revolution. So 7 times 4 gives us 28. And then that gives us the RPM. We'll plot the RPM. Everything else here is, let me show you on the board. So the ground, this is the H bridge. H bridge controls sort of counterclockwise, clockwise movement. This can control 2 motors, one on each side, one on left, one on right. Right is open. This is power, this blue thing right here, and that one is connected to the motor. So that's giving power and giving the phase, like the clockwise, counterclockwise input from the white wire to the motor. That's the 9-volt battery. We will run this. So the way in MATLAB, you do have to set up your modeling. Not a big change. Basically, you say Arduino Uno, whatever Arduino you have. When you run it, it basically compiles the code, and then that code gets converted to hex code, giving your motor rotations. There you go. And you can see your output of what you produced. We can plot this out. So we say plot RPM, and voila, there you go. So there was the motor hit a surface, so that's why you see that bump. But right now it's going at 70% duty cycle. It's going about 11,000. 10,100 RPM, and it's like constant over there. Thank you.